So we continue our discussion on frets. And remember, we are talking about square frets, and we assume the profile. The profile of screw frets is looks like this, and which we call the square frets. And if you pick a screw from hardware stores, that usually those are 60 degrees ones. And we use we unwind a revolution, and we have the length is 2 pi r, and the x-axis, the distance in x-axis is called lead, which we say it is L. From here, of course, we can get a angle theta. It's okay. Now we look at let's look at this. We look at this figure, and I will explain what's happening here. Wait a minute. And should I? Oh, let me put it here. So we have two plates here. We have two plates here, and those are joined by a screw, right? So this is a plate. This is one plate, and this is another plate. And this is the nut, and this is the bolt. Can you understand this figure? So we have a nut here, and then we tighten the bolts by rotating this, right? Now, how do we draw the free body diagram of this of the bolt and the nut, and what's happening here? So let's look at the free body diagram of the plates. For the place here, so the bolts and nut, do they put compression onto the plates or tension onto the plates? Do we compress them, or do we have tension there? Compression. We have compression on the plates. Okay. We have compression on the plate. That's the first thing. So we have action and reaction. So now we look at the bolts and nuts. So if we have bolts and nuts, if we have this, if the bolts and nuts acts on compression onto the plate. So what is the reaction from the plate to bolts and nuts? So this is compression, so this is tension. So wait. Now, as we always say that free body diagram should be drawn on rigid bodies, but this is not a rigid body because the nuts can go up and down, right? The nuts can go up and down. So we draw a free body diagram of the nuts. This is the nuts. And of course inside the nuts we have threads, right? We have screws here. We have threads here. Now, of course that from the first thing that we have the force acting from the plate onto the nuts, which is the red. The red forces here. But it should be in equilibrium, so summation F should be equal to 0. So how do we balance the force here? Remember the bolt. Oops. Remember the bolts here. So afterwards, take one of them. Take this and have a look. So we have this is too small. Now there's the bolt and the nuts, and the bolt and nuts experience has tension because of the plate. So and the bolt is the thread from the bolts would have a force. This is it clear? Not, seems not. So let me use another color. Which color should I use? Orange. Can you see it? So this is the bolt, okay? Sorry. And that is the bolt thread. So because the bolt is pulling downwards, so it would if the nut is here, the bolt pulling downwards, so the bolt thread would have contact with nuts here. So of course it will happen on all threads, right? On all revolutions. This is this one, and then we have it here. In terms of the force, because it has contact on this surface or on this surface, of course it's on this surface, that we can draw a contact force, and we can draw a contact force here. If this is tension T, then we have the same force T acting from the bolt to the nut on the thread. So this is what's happening in the bolt and nut.